Okay, so in this video here, we have a higher degree polynomial and we're being asked to find all of the zeros. Now, they do provide you with one zero, and that is going to be right here, okay? And it's a complex zero. So let's talk about how we're going to do this problem because it's not very obvious. And typically, when you're thinking about factoring polynomials, you may be thinking of quadratics. Well, you can see right here that I'm dealing with a 7th degree polynomial. So we have to talk about how we're going to do this problem. So let's go for it. So again, they do give you one of the zeros. It is x is equal to 1 plus I. Now, think about your complex numbers and imaginary numbers. I comes from the square root. So if this zero right here exists, that means x equal to 1 minus I must also exist, okay? So right now, we technically have two zeros, and they're going to be complex. Now, if you go back to the original up here, try to pull out a greatest common factor. That's always a good move. And if you look at all of your terms here, they do have a variable in common, meaning I can pull out an x. So another zero here is going to be x is equal to 0. Because remember, that will technically be a factor. And when you solve that factor x, it will be x is equal to 0. So right now I have 3 zeros. I need 4 more. And I know that I need 4 more because the degree on my polynomial is 7. Okay? So your degree will always match how many zeros you have. So right now I have 3 of them. I need 4 more. How am I going to get those 4 more? So this is where you have to get a bit creative and you have to think of long division. Because we know that when we divide a polynomial, we'll bring it down a degree and we may be able to factor from there. So for example, if I can divide this 2 times, I can bring it down to a 4th degree polynomial and then maybe from there I'll be able to factor it. Because remember, right now my degree is 7. I did pull out an x, so that will make it 6, right? So technically this would become 6 now, and this would be 5, and this would be 4, 3, 2, 1, and this would be gone, right? So technically it would be a 6th degree polynomial now, since I'm factoring out that x. And so if I can divide it 2 times, again, I'll make it a 4th degree polynomial. And look, I have 2 known zeros right here. I can go ahead and use these to divide, and that will bring it down 2 degrees. So these are complex zeros though. So what you're going to want to do before you divide is expand it out, okay? And that will serve as our divisor. All right, so let me show you how it's going to be done. So we're going to take our complex zero here and here, and we're going to put them back in factored form, multiply it out, and that will be our divisor when we divide, okay? So for example, it will look the following way. You'll have x minus 1 and then minus I. There's one factor. And then the other one will be x minus 1 and then plus I. And from here, we just have to multiply it out. So again, I have to distribute 3 terms here. And when it's all said and done, I'll have 9 terms in total. So I'm going to start with x and I'm going to multiply by x. I get x squared. And then here I get negative x. And then I'll get plus ix. Okay. Now going on to this term here, I'm going to distribute 3 more times. I get negative x, and then I get plus 1, and then I get negative I. And then going on to my last term right here, I get negative ix when I distribute. Then I get positive I, so I put positive I here, and then I get negative I squared. Negative I squared, but remember, I squared is really negative 1. So if I replace this part with negative 1, those 2 negatives will make a positive. The whole thing becomes positive 1. So I'm going to replace it with positive 1. Okay. Now from here, you should have terms that will cancel out. So for example, ix and negative ix, those cancel. And then I have a negative I and a positive I. Those will cancel. And then combine like terms. So I get x squared and then negative 2x, right? Negative x and negative x. And then 1 plus 1, I get 2. Okay. So this is going to be our divisor. And we should get a remainder of 0 when we do this because, again, these factors are zeros of this polynomial up here, okay? And from here, why don't we go ahead and scroll down just a little bit so we have room. And again, this part right here is going to be our divisor because it came from these factors right here, which are zeros of this polynomial up top. And so when I divide it, I should get a remainder of 0 because that's how it works out. If your divisor ends up being a factor of that polynomial, you'll end up with a 0, and we already know that it is. it gave it to us at the beginning. So we're going to go ahead and use that as our divisor. So I'm going to put here x squared minus 2x plus 2. And then we're going to go ahead and set up our division bar. And our dividend will be this polynomial up here. Again, we are factoring out an x, so make sure you're using the exponents that I rewrote above. So we're going to put here x to the 6th power, and then we have negative 2x to the 5th power, and then negative 30 x to the 4th power. Then we have plus 64 x cubed, and then plus 111 x squared. Let's go ahead and shift over just a little bit. That way I have room. And we're going to have to extend this here. And then we have negative 350 x and then positive 350. Okay. All right. So from here, we're just going to go ahead and divide it out. When it's all said and done, we should get a remainder of 0. And we're going to be looking at the quotient to see if we can factor it. And then we'll be able to get the remaining zeros. So let me go ahead and scroll down. So remember the rules here, you're trying to match this first term here when you do long division, meaning I'm going to have to multiply by x to the 4th power. So multiplying by x to the 4th power, and again, that's going to go to all 3 terms right here, okay? So I'm going to do x to the 4th power times x squared, I get x to the 6th power, and then doing my next term, I get negative 2x to the 5th power, okay? And then x to the 4th power times 2, I get plus 2x to the 4th power, put it in parentheses, and then a negative on the outside, and then we just subtract it, right? Now, it's important to note, I didn't talk about it, but if you skip any powers on your dividend, make sure that you're including zeros in there. Same thing on your divisor. Now, we don't have to worry about it here because we did not skip any powers, but again, just keep that in mind. So again, going back to this part here, this will cancel out, okay? Right here, this will also cancel out because of the 2 negatives here. So these will cancel because it's negative 2x to the 5th power plus 2x to the 5th power. And then right here, I'm going to get negative 32. So negative 32 x to the 4th power. Okay. Now, you want to make sure that you have 3 terms at all times because I have 3 terms on my divisor. I have to match it. Right now, I only have 1 term, so I actually have to bring down this term and this term for my dividend. All right, so I'm going to bring down plus 64x cubed. And I'm also going to bring down 111 x to the 2nd power. Okay, so now my goal is to match my first term right here. So that means I'm going to have to multiply by a negative 32x squared. So let me go ahead and scroll down. And I'm going to multiply by negative 32x squared. So negative 32x squared. That will give me the negative 32x to the 4th power. Then I have to do negative 32x squared times a negative 2x. We know that will be positive. So I get plus 64x cubed. And then negative 32x squared times 2, that will give me negative 64x squared. Okay, put it in parentheses, negative on the outside, and then subtract. So again, you can see how this is working out. This will always cancel out. And then looking at my next part here, this is also going to cancel out. So that works out nicely. And then right here, we have 111x squared minus a negative 64x squared. The 2 negatives make a positive. So you're essentially going to be adding here. And when you do that, you're going to get 175x squared, right? And then from here, I see that I have 1 term. I have to bring down 2 more terms. So I'm going to bring down this term, and then I should be done. Again, I should get a remainder of 0 here. So I'm going to bring down negative 350x, and then I'm going to bring down positive 350. And then again, I'm trying to match this first term here. So I have to multiply by 175. So let me go ahead and scroll down. And I'm going to multiply by 175. So plus 175. And that will give me 175x squared. 175 times a negative 2x will give you negative 350x. And then 175 times 2, you get positive 350. So again, in parentheses, negative on the outside. And you can see here that this will all cancel out. That's what we want. That proves that, again, our divisor is going to be a factor of that polynomial at the beginning. right? And we know that because it came from the zeros at the beginning, right? So this will all cancel out, meaning I have a remainder of 0. But the part that we're looking at is right here. So this is what we want to look at, and this is what we want to focus on, because that's the end result. And so can I factor that? Can I factor that quotient? Because again, if I can factor it, then I can get the remaining zeros of this original polynomial. And so it may not look like you can factor it at the beginning because you're not dealing with a quadratic, but this is a pattern, right? See how you have to the 4th power here and then to the 2nd power? That's the same pattern that you have on a quadratic. So if you have a quadratic in standard form, that's going to be ax squared plus bx plus c, okay? So that pattern is the same here, where technically I have an exponent of 1 here, and you can see that from here on my bx term, it doubles going to my ax squared term, right? 1 times 2 will give me 2. So if you go back to your quotient, you see that you have a 2 here. So if I double that, I should get 4, and I do right here. So we can factor this just like we would a quadratic, right? The same rules will apply here, okay, since we're following that pattern. And so that's what we're going to do. And so to factor, I like to do the AC method. It's up to you how you want to factor it though. So I'm going to go ahead and scroll down, and we're going to write here x to the 4th power minus 32 x squared, and then we have plus 175, okay? So you cannot pull out a greatest common factor here, but we can use the AC method. So if I do a times c, what will that give me? So again, I am kind of running out of room here, but let's do it over here. I'm going to do a times c. That's 1 times 175. So I get 175, okay? So I need 2 numbers when I multiply. That will give me 175, but add up to my b, which is negative 32. So that's definitely not obvious at first glance. You may have to test it out on your calculator. But those 2 numbers are going to be 25 and 7, and they both have to be negative. So it's going to be negative 25 and negative 7, because when I multiply them, I get 175. And then when I add them, I get the negative 32. Now, a is equal to 1. I can put it right in factored form. And so how that's going to look is the following way. Instead of writing x and then minus 25 and x minus 7, remember, it is to the 4th power here. So I'll have to put an exponent of 2 here and here, and then you're good, all right? And now you can solve it. Remember, this is technically equal to 0. So all I have to do now is solve these factors. So if I solve this factor right here, I move the 25 over and then take the square root. That will give me x is equal to plus or minus 5. Those are 2 zeros right here, okay? And then this one here, I have to move the 7 over and then take the square root. I get x is equal to plus or minus the square root of 7. There's 2 more. So we found them all. So I have 2 here, I have 2 here, that's 4. And then if you go up, right, we have 3 here. I have 1, 2, and 3. So we have all 7. And again, I know I'm dealing with 7 here because, well, the original had a degree of 7. That's going to match how many zeros you have. And so we're done, right? So there it is. We just found all the zeros of this polynomial. So I hope that you found this video helpful. I hope that you gained something from it. It was definitely a lot of work, and it was definitely a bit tricky. But again, the way we did it was by using long division, and we were able to bring down that polynomial several degrees so that then we could factor it, okay? So I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.